Now we're going to start solving inequalities. And if you watch the videos on solving equations, whether they're one-step equations, two-step, multi-step, ones with variables on both sides, if you're comfortable with that, this is going to be so easy, guaranteed. So here we got 2x minus 7 is less than 1. So just imagine, we're not going to change it to an equal sign, but treat your inequality sign, remember less than, greater than, less than or equal to, greater than or equal to signs, treat them as you would an equal sign. There's a couple of cases where we want to watch out for a few things, but we'll get to that in a second. So just treat it like an equal sign. So I'm going to add 7 to both sides. Remember, I want to undo what's being done to the variable, and I want to go about that doing reverse PEMDAS if you forget which things to undo first. So I'll undo that minus 7. These will cancel out. I'll have 2x is less than or equal to 8. And then I'm going to undo that multiply by 2. Divide both sides by 2. The 2's cancel out. And we'll have x is less than 8 divided by 2 is 4. So there is our answer. Any value of x that's less than 4 will satisfy this inequality up here. So we're going to go to 4 on the number line, which is going to be here. This is an open circle because it's not less than or equal to. And since it's less than, our arrow is going to go to the left like that. And let's just pick some values that are less than 4, plug them into our original inequality, and just see that they do satisfy the inequality, or they are part of our solution here. So let's take x is equal to 0. So these are just going to be some test points. So let's say x is 0. We'll have 2 times 0 minus 7 is less than 1. 2 times 0 is 0 minus 7. 0 minus 7 is negative 7. And negative 7 is definitely less than 1. So that checks out. If we did, I don't know, negative 1, x is, well, let's do negative 5. Why not? Or how about negative 10? It's not even in the range of our number line here, but remember this arrow, this orange arrow, it keeps going to the left. So we'll have 2 times negative 10 minus 7 is less than 1. 2 times negative 10 is negative 20 minus 7 less than 1. Negative 20 minus 7 is negative 27, and that's definitely less than 1. All right, 6x plus 9 is greater than or equal to negative 3. So again, just treat this as a two-step equation because that's what it kind of looks like. So I'm going to subtract 9 from both sides. Those will cancel. I'll have 6x is greater than or equal to negative 3 minus 9 is negative 12. Go ahead and divide both sides by 6. And then we'll get x is greater than or equal to negative 2. So there is our solution for this inequality. And then to graph it, we just find negative 2 on the number line. And this time it's going to be a fully colored in circle because we have this greater than or equal to. And then we'll draw our arrow to the right like that. And again, we can test a couple points if we want. Let's test x equals negative 2. So if I plug that into the original equation, or inequality, I should say, x times negative 2 plus 9 is greater than or equal to negative 3. 6 times negative 2 is negative 12. And then plus 9 greater than or equal to negative 3. Negative 12 plus 9 is negative 3. And is that greater than or equal to negative 3? Yes. Yes, it is. Let's pick x equals 100 because that's definitely greater than negative 2. So this should work out as well. 6 times 100 plus 9 is greater than or equal to negative 3. 6 times 100 is 600 plus 9 is 609. And that's definitely greater than negative 3. All right, 4x greater than negative 8. So this is just a one-step equation or one-step inequality. I'll divide both sides by 4 to cancel that out, and I'll have x is greater than -2. So again, I'll go over here to -2. This is an open circle because we don't see that greater than or equal to. And then my arrow is going to go to the right. And again, let's just do one test point. I just want to show this thing real quick. If we make x equal to -2 and plug it in, so 4 times -2 is greater than -8. Sorry, greater than, not greater than or equal to, greater than -8. 4 times -2 is -8. And is that greater than -8? No, it's not. -8 and -8 are equal to each other. Again, that's why this circle here is open, because when we use that value of -2, we get an untrue inequality. So it has to be an open circle. All right, let's make things interesting with this one. So now we have variables on both sides of the inequality. So go back and watch the video I did for solving equations with the variable on both sides, and we'll do the same thing here. So I'm going to move all of my variable terms to the left side of the inequality sign, and then all the constants to the right side. So I have a positive 5x on the right side, so I'm going to subtract 5x from both sides to move it over to the left. These will cancel out, and over here I got some like terms I can combine, so I'll have -5x minus 5x, which is going to be -10x, and then bring everything else down, plus 2 less than or equal to -78. And then I'll subtract 2 from both sides and get -10x is less than or equal to, or these cancel out. What's that? -80. All right, here I'm going to divide both sides by -10 and get x. Now, very careful here. Whenever you multiply or divide both sides of an inequality, so this is only for when you multiply or divide both sides of an inequality, not with addition or subtraction. When you multiply or divide both sides of an inequality by a negative number, your sign is going to flip. So the sign is going to flip going the other direction, so we'll have x is greater than or equal to 8. And let's just test some points to see that that's true. Or we'll just do one test point. Let's say x is equal to 10. Pick an easy number to work with. So -5 times 10 plus 2 is less than or equal to 5x minus 78. Or I should do 5 times 10 minus 78. So remember, I'm using this original inequality, which is why the sign is flipped compared to our answer. So when I do multiplication here, I'll get -50 plus 2 is less than 50 minus 78. -50 plus 2 is -48. Less than or equal to 50 minus 78 is going to be -28. And -48 is more negative. It's less than -28. So again, remember, whenever you multiply or divide both sides of an inequality by a negative number, like we did right here with this divide by -10, you have to flip the sign. You have to flip the sign if it's less than or equal to, like it was here. It's got to then become greater than or equal to here. And then don't forget to graph your solution for this inequality. So we've run out of space here. We need to get to -8. So I'll just add a couple more lines here to get to 8. And then I'll do a closed circle there because it's greater than or equal to. Then my arrow is going to go to the right. All right, x divided by -7, or x over -7 minus 9 is less than or equal to -1. So I'll start by undoing that -9 by adding 9 to both sides. Those will cancel. I have x over negative 7 is less than or equal to 8. So to undo that divide by 7, I'm just going to multiply by negative 7 on both sides. Those will cancel. And remember, since we multiplied both sides by a negative number, we got to flip the sign. So I'll have x is greater than or equal to negative 56. So for my number line, I can just pick any spot to be negative 56. So I'll just put it right in the middle. Why not? So negative 56. These larger tick marks are 5 away, so this is going to be negative 51 if we're going more positive, and this is going to be negative 61 going more negative. So I'll do my closed circle at negative 56, and then we are going to the right because it's greater than or equal to. All right, negative 2/3 x plus 13 is greater than 5. So I'll start by subtracting 13 from both sides. Those will cancel out. I'll have negative 2/3 x greater than, let's see, that's going to be negative 8. Yeah, negative 8. And since I have a fraction as my coefficient, I'm going to multiply it by the reciprocal to cancel it out. So I'll multiply both sides by 3 over negative 2, or negative 3 over 2. Doesn't matter where I put the negative as long as there's only one. It can go in the numerator, the top number, or the denominator, the bottom number. So I'll do that over here, 3 over negative 2. So on the left side here, the negative 2's will cancel out, the 3's will cancel out. And remember, we multiplied by a negative number. Yeah, it was a fraction, but still, we multiplied by a negative number. So that means our sign is going to flip. So we'll have x is less than, and then now we just multiply these numbers over here. I might make negative 8 a fraction to make it easier. So that's going to be negative 24 over negative 2, which is going to be x is less than 12. So I'll put 12 right in the middle here. To the right, it's going to be 17, and then over here is going to be 7. So this is just less than, not less than or equal to. So open circle, arrow going to the left. All right, negative 5 is less than 8x over 7 minus 4. So we can read inequalities going left to right. That's fine too. But I and most people like to have our variable terms on the left side of the inequality. So you can also read it going right to left. So this expression is greater than that number. So let me just write it that way. I'll write it as 8x over 7 minus 4 is greater than negative 5. So I'll add 4 to both sides. These will cancel out. So I'll have 8x over 7 is greater than negative 1. Since I have a fraction as my coefficient for x, it's 8/7. I'm going to multiply both sides by 7/8. So here as well. And the 7's will cancel out, the 8's will cancel out, so I'll be left with x is greater than negative 7 over 8. So I don't know what that number is as a decimal off the top of my head, but I know 7/8 is really close to 1, because 8/8 is equal to 1. So 7/8 is going to be just a little less than 1, but we have negative 7/8. So this is going to be probably somewhere like right there, just before negative 1. So I'll do my best to do a open circle there. And then it's greater than, so we're going to be going to the right, like that. All right, negative 10 times 1 minus 4c in parentheses is less than negative 10. So we can use the distributive property. I can multiply that negative 10 into the 1 and minus 4c. So negative 10 times 1 is negative 10. Negative 10 times negative 4c is positive 40c, less than negative 10. And we didn't change the sign there because we didn't multiply both sides by negative 10. We just stuck to the left side. All right, now we just solve, because it's not an equal sign, but we'll treat it that way, solve for c here. So I'm going to add 10 to both sides to cancel out that negative 10. And it actually cancels out there as well. So we'll have 40c is less than 0. And then I'll divide both sides by 40. To cancel those out, I'll get c is less than 0. 0 divided by 40 is 0. So I could put 0 in the middle there, 5, negative 5. Open circle at 0, and then it's less than, so we're going to do our arrow going to the left. All right, more distributive property here. So I'm going to distribute this negative 3 in there, into that parentheses. I'll get negative 3 plus 18x is greater than 18 minus 3x. Okay, so what I'll do now is I'll add 3x to both sides, because I want to get my variable terms to the left side. So these will cancel out, and I'll have negative 3 plus 21x is greater than or equal to 18. Let's move this negative 3 to the right side, so I'll add 3 to both sides to do that. Those will cancel, and I'll have 21x is greater than or equal to 21. Divide both sides by 21, and we get x is greater than or equal to 1. So I'll put 1 here, 6, and then negative 4. And really, we could have done it, let's just make it nice and symmetrical. 0, 5, and negative 5. Here's 1, and we'll color in that circle or shade it fully in because it's greater than or equal to. And then it's greater than, so we're going to be going to the right. Okay, a lot going on with this one, but just take it step by step. So let's distribute this negative 2 into that parentheses. So I'll have 11 minus 10. Negative 2 times 5 is negative 10. And then negative 2 times 6x is minus 12x is greater than 6. We'll do the same thing here. Distribute that 6 in, so we'll get negative 12x plus 48 plus 11. I'll combine some like terms first. So here, 11 minus 10 is going to be 1, and then minus 12x is greater than 48 plus 11 is 59, so I'll have negative 12x plus 59. And then let's see, I'll subtract 1 from both sides to move that 1 over. So I'll have negative 12x is greater than negative 12x plus 58. And then I'll add 12x to both sides. These will cancel out, and actually so will these. So what we're going to have here is 0 is greater than 58. Well, that is correct. We did all the steps right, but that doesn't make any sense. 0 can never be greater than 58. So for this inequality, our answer would be no solutions. And you can test all kinds of values for x in the original inequality to see that you're never going to get anything that makes sense. So sometimes that happens with inequalities. You'll get no solutions as an answer, and typically it'll look something like this, where a number is greater than or less than a number when it's actually not. Like here, 0 is never greater than 58, even though we got it. So when that happens, our answer is no solutions.